Good morning, grade 9s, to our grade 9 Natural Sciences WorksheetCloud lesson. I'm absolutely delighted that you could join us today. If you have a question during the lesson, please send an email with your question to grade9@worksheetcloud.com. I absolutely love this quote by Muhammad Ali. Don't count the days, make the days count. And during this time, it is very difficult not to count the days and cross them out. And sometimes it's even more difficult to make the days count. But I think the fact that you're up and you're learning and you're listening and you're taking control, you definitely are making every moment in your day count. So keep up with it, grade 9s. I really am proud of your motivation and determination to make every day count during this time. So, my name is Mrs. Ernston. I am the WorksheetCloud Grade 9 Natural Sciences teacher. Please get everything ready for your lesson. You'll need some paper, pens and pencils, any of your textbooks if you have. We are doing our final lesson in balancing equations. So, if you have just joined us today, please will you go and have a look at our previous 3 lessons. They cover all the rules and hints and tips and everything you need to know about balancing equations. And then the lesson previous to this is an online simulation, and I'm carrying on with that online simulation today. So if we have a look at the main focus of our lesson, we're going to continue with our online simulation. And then just to double check, what does it mean to balance in a chemical equation? How can you tell if it's balanced? And in the process, we'll have a look at the rules to balancing equations. We're going to have a look at this online simulation that you can go and have a look at anytime you want. So you can pause the screen now and you can copy down the URL. It's over here, written in blue and underlined. And after this lesson, you can go and have a look and you can explore and have fun and play and engage. This lesson is done in conjunction with the game level 3. So if you go to the worksheet section, you will find each of the chemical reaction equations and you can go through and you can balance them together with me. Or at the end of the lesson, go onto the worksheet section and see if you can remember how to balance the equations. So when you put the URL in, it might bring you up to a page that looks like this. You may need to download it, or you can just simply click on the play button here. And if you do that, it will take you through to this page here. And we are going to be looking at the game section today, level 3. In our previous lesson, we looked at the introduction section, which involves balancing 3 equations, and we played the game level 1 and level 2. So in our previous lesson, we did level 1 and we did level 2, and today we're going to move on to level 3. So if you've just joined us, please will you go and look at the previous lesson and see if you can do the equations there. So level 3 is quite a challenge. It is probably not expected in grade 9 for you to be able to do these, but if you understand it, it will make grade 10 that much easier. So let's just give it a go. So we start out by making 1 molecule of each of these elements and compounds react together. So we have 1 molecule of nitrogen gas, we have 1 molecule of water, making 1 molecule of NH3 and 1 molecule of O2. So you can balance this in 2 ways. You can do the ball diagrams that I'm going to show you here, or if you go to lessons 1, 2, and 3 on balancing equations, I teach you to write out the equations. Underneath the equation, we use a table method whereby we write down the names of the elements in the reactants and the names of the elements in the products, and we count the atoms and we balance it using that method. There are lots and lots of different methods for you to use, and lots of teachers teach it in lots of different ways, but hopefully this little simulation just makes it a little bit more visual and a little bit clearer. And then when you get back to school, you can just double check with your teacher if they have got any clever, good, quick and easy methods for you to use. So if we have a look here, we have 2 times by 1 nitrogen atoms, and the diagram shows 2 nitrogen atoms. Then there's no more nitrogen. Then on our products, we have 1 times by 1 nitrogen atom, so there is 1 blue nitrogen atom. Then we have 1 hydrogen atom, so there's 1 times by 1, oxygen, there's the 1 red oxygen atom. And here we have 2 times by 1, so that gives us 2 red oxygen atoms. And then hydrogen, on our reactant side, we have 2 times by 1, so that's 2 hydrogen atoms, these small white circles. And here we have 3 times by 1, 3 white circles. So the general rule that we'll follow is we'll start with the metals first. If there's no metals, you start with any other non-metals, and we leave the hydrogen and oxygen till last. So if we start with a nitrogen, on this side of the equation we have 2 atoms, on this side of the equation we have 1. So if we add another molecule, we now have 2 atoms of nitrogen on the product side and 2 atoms of nitrogen on the reactant side. So our nitrogen is now balanced. But in the process of adding another molecule, we added another 3 hydrogens. So on this side, on the reactant side, we still have 2 atoms of hydrogen, but on the product side, we now have 3 times by 2, which is 6. 1, 2, 3, 4, 5, 6. So now our hydrogen is unbalanced. So if we've got 6 atoms of hydrogen on this side and 2 on this side, let's balance it out here. So now we have 4 hydrogen atoms, 1, 2, 3, 4, but we need to get to 6. So we add another one, 1, 2, 3, 4, 5, 6. So we have 6 water molecules. So nitrogen is still balanced, hydrogen we are sitting, and hydrogen is now balanced. Oxygen, here we have 1, 2, 3, and here we have 1, 2. So what we do to the one side, we'll do to the other. So that, if we add another molecule here, that gives us 4. 1, 2, 3, 4. And here we've got 1, 2, 3. So let's add another molecule here. So that gives us 1, 2, 3, 4, 5, 6, 7, 8 water molecules. Here we have 1, 2, 3, 4, 5, 6. So if we add another one, that's 7, 8, 9. So let's just carry on and try and balance out our water. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. So let's take that up. It's now 10. And so here we now have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Add another one, 11, 12. So now 2 times by 6 gives us 12. 3 times by 4 gives us 12. So now our hydrogens are balanced. So let's now go and try and balance our nitrogens and our oxygens. So here we have 1, 2, 3, 4 nitrogens. Here we have 2, 3, 4. And oxygens, here we have 6. 1, 2, 3, 4, 5, 6. Here we have 1, 2, 3, 4, 5, 6. So have a look at that and see if we have it balanced. So according to the diagrams, it looks balanced. Let's just check here. So 2 times by 2 is 4. 4 times by 1 is 4. 6 times by 2 is 12. 3 times by 4 is 12. 6 times by 1 is 6. 2 times by 3 is 6. We check our answer and it's balanced. Let's do the next one. Okay, so we'll make 1 molecule of each of these react. And we just have a look at the elements that are reacting. So we have carbon, oxygen, but just be aware that oxygen does appear twice, and we have hydrogen. Here we have carbon, we have oxygen, it appears twice, and hydrogen appears twice. So if we have a look here, we have one carbon atom, and here we have two carbon atoms. Carbon atom is gray, and here it's gray. So if there's two carbon atoms on this side and one on this side, let's add another carbon atom. So now our carbon atoms are balanced. So now it doesn't really matter whether you pick the hydrogen or whether you pick the oxygen, because oxygen appears twice here and it appears here. So we're just going to go through this slowly and carefully, and what we do to the one side, we do to the other side. So if we have a look at the hydrogen molecules, 1 times 2, we have 2 hydrogen molecules here. Here we have 5 plus 1 is 6. 1, 2, 3, 4, 5, 6. So here we have 6, here we have 2. If we balance it out, that now means we have now 4 hydrogens, and that now means we have 6 hydrogens. So our carbons are still balanced and our hydrogens are still balanced. Let's go and have a look at our oxygens. So here we have 4 oxygens plus another 3. So it's 1, 2, 3, 4, 5, 6, 7. Here we have 1, 2, 3. So if we add another 1, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So sit back, have a look, and check if this is correct. Yes, it's balanced. Well done. Okay, let's go and give one molecule of each. And let's go and see if we can balance this out. So again, if there's any metals, start with the metals, or any non-metals, start with the non-metals. Leave the hydrogen and oxygen for last. So nitrogen, on our reactant side we have 1, and on our product side we have 1. Oxygen, we have 2 oxygen atoms on our reactants, and here we have 1, 2, 3. Here we have 1, 2, 3 hydrogen atoms, and here we have 2. So if we just check down here, 1 times by 1 is 1, 3 times by 1 is 3, 2 times by 1 is 2, 1 times by 1 is 1, 2 times by 1 is 2, 2 times by 1 is 2, and 1 times by 1 is 1. So now you might be sitting thinking, well, do we start with the oxygen first or do we start with the hydrogen first? So because oxygen appears twice over here, let us just start with the hydrogen. So nitrogen's balanced, so we have hydrogen on this side and hydrogen on this side. So let's go and balance the hydrogens, and then we'll worry about our oxygens. So if there are 3 hydrogens this side and there are 2 hydrogens this side, if we balance that out, that gives us 4. 1, 2, 3, 4. And here we have 1, 2, 3. So let's add another one. So that gives us 1, 2, 3, 4, 5, 6. Here we have 1, 2, 3, 4, 5, 6. So now our hydrogens are balanced, but in the process, I have added an extra atom of nitrogen. So here we now have 2 nitrogens, here we have 1. So let's add another one. So our hydrogens are now balanced, our nitrogens are now balanced. Let's try and look at our oxygens. Here we have 2, here we have 4, 1, 2, 3, 4, plus another 3, 1, 2, 3. So we have 1, 2, 3, 4, 5, 6, 7. So we can add another molecule, that's 1, 2, 3, 4, 5, 6. But now if we add that, that's 7, 8. 7, 8. So here we've got 1, 2, 3, 4, 5, 6, 7. Well, let's add another one, 8. So now our oxygens are balanced. Now, what I've done is I have unbalanced our hydrogens. So here, let's just double check. 4 times by 2 is 8, so that's 4, 5, 6, 7, 8. Okay, oxygen is now balanced. Nitrogen is now balanced, but hydrogen Here we now have 6. 1, 2, 3, 4, 5, 6. Here we have 1, 2, 3, 4, 5, 6, 7, 8. So let's add another hydrogen on here, not another molecule on here. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. So another molecule here. That gives us 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. It gives us 10, 11, 12. So if we add another molecule here, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2 times 6 is 12. Here we have 3 times 4 is 12. So our hydrogens are now balanced. Are our nitrogens balanced? 1, 2, 3, 4. Here we've got 2, 1, 2. So we add another one. 1, 2, 1, 2, 3, 4. So nitrogens are now balanced. Hydrogens are now balanced. Let's now go and see the oxygens. So here we have 8. Here we have 8 plus another 6. That's 14. And here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I'm wondering if we look at this equation now, if it's balanced. So let's check and have a look. Yes, well done. That was a really, really tricky one. And that's the thing with balancing equations. It is tricky, but at the end of the day, if you just go slowly and carefully, what you do to the one side, you do to the other side, and remember to always count your atoms, you should eventually be able to work it out. Okay, the challenges get a little bit more tricky. Let's have a look here. So we've made one molecule of each in the reactants and in the products, and now let's go and try and balance these equations. So the elements we have are carbon, hydrogen, and oxygen. Carbon is the gray circles, oxygen the white, hydrogen the white circles, oxygen the red circles. Carbon, the side is gray, oxygen is red, and hydrogen is white. So this side of the equation we have 2 times by 1 carbon atoms, and here we have 1 times by 1 carbon atom. Hydrogen atoms, 6 times by 1. 6, so that's 1, 2, 3, 4, 5, 6, and here we have 2 times by 1, which is 2. Oxygen atoms here, 2 times by 1 gives us 2. Here we find oxygen in 2 places, so remember to add them both together. 2 times by 1 gives us 2 here, plus 1 times by 1 there, which gives us 3. So let's start and try and balance the carbon. So if there's 2 carbons this side, there's 2 carbons that side. Now our carbons are balanced. So now, because we have oxygen in 2 places here and hydrogen only in once, let's go and try and balance our hydrogens. So here we have 6 hydrogens and here we have 2. So that gives us 3, 4, 5, 6. So 2 times by 3 gives us 6. 6 times by 1 gives us 6. So our carbons are still balanced and our hydrogens are now balanced. Let's look at our oxygens. 1, 2 on this side. And here we have 1, 2, 3, 4, 5, 6, 7. So here we can go 1, 2, 3, 4, 5, 6. But if we have another one, it takes us to 8. So let's just add another molecule here. So here we have 1, 2, 3, 4, 5, 6 hydrogens. Here we have 1, 2, 3, 4, 5, 6, 7, 8. So we balance that one out. So we now have 12 hydrogens here. So let's put 12 hydrogens here. So carbons, we've got 1, 2, 3, 4, 1, 2. Let's go and add 3, 4. So our carbons are balanced. 2 times by 2 gives you 4. 4 times by 1 is 4. Our hydrogens are balanced. 2 times by 6 gives us 12. 6 times by 2 gives us 12. Let's go and have a look at the oxygens. So 4 times by 2 gives us 8. And here 8 plus 6. That's 8, 9, 10, 11, 12, 13, 14. So here we've got 1, 2, 3, 4, 5, 6, 7, 8. That's 9, 10, 11, 12, 13, 14. So by the looks of things, our carbon is balanced, our hydrogens are balanced, and our oxygens are balanced. So should we see if we're correct? Yes, well done. And on to our last challenge of today. Let's see if we can get this right. Let's start with one molecule of each. And let's have a look here. So we have one carbon here and 2 carbons here. We have 2 oxygens here. So carbon is red, carbon is gray, oxygen is red. So we have 2 oxygens there and 1 oxygen there, hydrogen 2. Here we have 2 carbons, 2 hydrogens, and 2 oxygens. So if we have 1 carbon this side, so we have 2 carbons this side and 1 carbon this side. So let's balance out the carbon. So carbon is now balanced. So let's see if we can balance out hydrogen. Here there's 2 atoms of hydrogen, and here there are 2 atoms of hydrogen. Oxygen, we have 1, 2, 3, 4, 5. And here we have 1, 2. So that's going to give us 3, 4. But that's going to give us 5, 6. So if we balance it out, that's 1, 2, 3, 4, 5. We give another one there, 6. So are carbons still balanced? Yes. 2 carbons, 2 carbons. Hydrogen, 2 times 2 is 4. 1, 2, 3, 4. Here our hydrogen is not balanced. It's 1, 2. So we'll come back to that. Let's just check oxygen. 2 times 2 and 2 times 4. That's 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we just have to balance out our hydrogens. So here we've got 4. Here we've got 2. So let's add another molecule. So now our hydrogens are balanced, but in the process, I've added another carbon. So we've got 1, 2, 3, 4 carbons. So let's rebalance this out. 1, 2, 3, 4. So carbon is now balanced. Hydrogen, is that balanced? 1, 2, 3, 4. 1, 2, 3, 4. Yes, and let's have a look at oxygen. So that's 4 and 6. 1, 2, that's 8 and 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if we just look at the balanced equation at the bottom, 1 times by 4 gives us 4, 2 times by 4 gives us 8, plus there's oxygens here, 2 times by 1 gives us 2, so that's a total of 10, and we have 2 times by 4 hydrogens. 2 times by 2 gives us 4 carbons, 2 times by 2 gives us 4 oxygens, and 2 times by 5 gives us 10 oxygens. And it's balanced. So well done. We managed to get 5 out of 5. So playing those balancing chemical equations was really quite tricky today, and I'd say that most of those balancing equations is a process of trial and error, especially, and it's quite nice that you can play with the game and add and take away molecules as you want. But generally, the level 1 equations we did today, you're more than likely only going to get to in grade 10. But well done for taking on the challenge, and thank you for sticking with me through the course of the lesson. So as a summary for today's lesson, why don't you write down the equation written here? It should be balanced already for you. But in writing it down, why don't you, on half a page or a page, write down a complete summary of balancing equations? So what do the coefficients mean? What do the subscript mean? What does the letter mean? What do the arrows mean? Where are the reactants? Where are the products? What are the rules to balancing equations? And what little tips and hints have you learnt along the way? So I suggest spend some time going over the summary, because we've come to the end of our balancing equations section. So there are lots of previous worksheets where you can go through how to balance them. The memos are attached, so you can double check whether you got the answers right or wrong. And we'll be moving on to a new section. So grade 9s, thank you for watching our lesson today. And this lesson was brought to you by WorksheetCloud, and I look forward to seeing you at future lessons. Goodbye.